Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome to this third lecture of Module 8 on rock load and support system. In previous lectures we have elaborated about empirical approach for estimation of rock load. Now in these lectures we will continue with the empirical approach carried out by some of researchers except Tarjagi 1946 and Deer et al 1970, and semi-empirical approach for determination of rock load or ground pressure of a geoground. In this lecture we are going to emphasize about semi-empirical approach in detail. For this we are going to introduce the concept and then about empirical approach and followed by semi-empirical approach, the introductory aspect of structural defect approach as initiation. Friends, as you know, we have estimated the rock load using concept of Tarjagi for 9 rock classification and added RQD as per suggestion proposed by Deer et al. In 1970 on the base of Tarjagi classification proposed in 1946. Besides this, we have approaches based on rock mass classification carried out by Beniavsky in 1967 to 1973. Then rock mass categorization carried out by or proposed by Barton et al. In 1974 in terms of Q index. Then utilization of this Q system and RMR by later workers or later derived rating system and indices proposed by other researchers. As far as this rock mass quality index is concerned, the rock mass quality Q is a very sensitive index and its value ranging from 0.001 to 1000. Between 0.001 to 1000, the Barton and his co-researchers have divided the rock mass or rock strata as integration of rock mass in certain category. You can see the 3 column here along with some adjective and the 3 column here along with some adjective. These adjectives attach with good as very, extreme, exception. Then here very, extreme and exception. If we are going to see from the lower side, we can categorize rock mass as exceptionally poor, extremely poor, very poor, poor, fair, good, very good, extremely good and exceptionally. The Q value ranging between 0.001 to 0.01 is recognized as exceptionally poor. Between 0.1 to 0.01 to 0.1 it is recognized as extremely poor. From 0.1 to 1 it is recognized as very poor. And from 1 to 4 poor, 4 to 10 fair, 10 to 40 good, 40 to 100 very good, 100 to 400 extremely good, and 400 to 1000 and more exceptionally good. But the classification is a limited value between this 0.001 to 1000. If we are going to see from our engineering decision purpose, then we can categorize these classes in 3 groups. Green, as the signal is a green, recommended for safe construction or development of engineering work belonging to exceptionally good, extremely good, and very good and good. These rock types we are recognizing suitable for construction work, therefore form under group 1 and here presented by green color, green signal. Then here rate GFE, exceptionally poor, extremely poor, very poor. In this exceptionally poor and extremely poor categories recognized as danger zone and not recommended for construction without any treatment. This green zone recommended for economical and technically sound construction of engineering structure without any doubt or uncertainties regarding the behavior of geoground. However, this red signal zone belonging to this G category, D grade and F grade presented by exceptionally poor and extremely poor fall under group 3, require deep level of preparation and treatment before implementing any defined engineering. Then in between these two, lying in between this good 1 and 3 as a 2, ranging from the categories as very poor, poor, fair and good, where very poor and poor requires treatment, but the level of treatment gradually decreases when we are moving from E to C in group 2 type of rock. Friends, we have good concept how to calculate Q. Q is simply, as you can see here, RQD by joint number, rating for joint number, into joint roughness JR by joint alteration about the weathering condition and the filling materials and others, then joint water reduction factor, then stress reduction factor. This stress reduction factor is representing about in situ stress condition and tectonic stress condition, where this JW is representing about the saturation, the strata or rock mass is partially saturated, fully saturated or fully dry. Joint roughness and joint alteration, these two combination is representing the shear strength of rock mass, particularly the interblock shear strength, and RQD and JN representing about the crude measure regarding the block size. If we are going to see this relationship proposed by Barton et al., Q is equal to, you can see here, RQD JR by J, JW by SRF. RQD by JN is representing about the block size of strata, means the nature of strata. Strata or ground is made up of big blocks or small block or sand-side block or fractured block. So through these quotients we can recognize about the nature of geoground. Then about the strength relation, this JR by JA, joint roughness by joint alteration, representing about the interblock shear strength, means a indication regarding the shear strength response of geoground or strata. Then third quotient representing JW by SRF, where SRF is representing tectonic stress or in situ stress and JW is representing about the saturation condition. So we can say that about the surrounding condition. So a rock of particular nature, or in another word we can say that rock strata of particular nature having specific shear strength and located in particular surrounding condition can be quantified with help of this index philosophically written by Q. Utilizing this Q index, the number of researchers and workers, engineers, geotechnologists have utilized to determine rock load or ground pressure. The approach made by Barton et al. In 1974 based on Q, he has estimated the rock load. PV is representing vertical pressure. The vertical pressure can be easily calculated by utilizing the concept of JR joint roughness and the rock mass quality index. Very simple relation, 0.2 by JR multiplied by Q power minus 1 by 3. If we are going to create here, you can see this is the strata where we are going to create this opening. Due to creation of this opening, there is a formation of damage zone. This damage zone is going to create rock load or ground pressure or support pressure on the support system. Which support system we are going to install here? The load vertical acting on the crown side of excavated opening recognized as PV, where the wall side pressure we are going to recognize by the PH. So PV is equal to 0.2 by JR multiplied by Q power minus 1 by 3. However, in case of the wall side pressure, it is the same 0.2 divided by JR multiplied by QW. QW means Q for wall condition, power minus 1 by 3. If we are going to see about the range of Q value and the wall factor, means for the QW, if the range of Q value is more than 10, then the wall factor is of 5.0 Q. If the range of Q 0.1 to 10, then the wall factor or QW 2.5 Q, and if it is less than 0.1, then it is simply Q. Utilizing this value for the QW, we are going to estimate about the pressure acting on the walls of opening. Pressure acting on the walls of opening. This is the damage zone. This side pressure horizontal. Here pressure PV. Here PH. Condition: if the number of joint set present in geoground or rock strata or rock mass is less than 3, then the PV requires some modification. Very simple modification: 0.2 joint number power 0.5 means half divided by 3 JR, and overall that multiplied by the Q power minus 1 by 3. For horizontal pressure acting on wall side, 0.2 Jn power half divided by 3 JR multiplied by Q power minus 1 by 3. These two you can see. PV is equal to 0.3 Jn power half, Jn power half, J1 0.2 Jn power half divided by 3 JR. This multiplied Q power minus 1 by 3. In case of the pH, the same 0.2 by 3 Jn power half into JR multiplied by QW, Q for wall power. They felt that the short-term support pressure can be determined after replacing this Q by 5Q to get a good result or more compact and authentic result as per their consideration. Using the same concept along with some modifications, the ANAL utilize RMR parameters which we initially discussed in our previous discussion. Ground pressure PV can be measured in terms of RMR and unit weight of rock as well as the width of opening. So 100 minus RMR divided by 100 into unit weight of rock mass and the width of opening. As per Goyal and Jethwa, 1991, they have proposed PV ground pressure PV is equal to 0.75 B power 0.1 into H power half minus RMR divided by 20 RMR and presented the results are both measured in MPa. Similarly, Rajendra Bhasin and Grimstad 1996 has proposed the measurement for ground pressure as a vertical pressure. The simple way 40 B by JR multiplied by Q power minus 1 by 3 measured in term of kilopascal. This condition was applicable for rock mass quality, means Q value less than 4, where the B is representing span of or width of the opening, and here H is height of OB. Suppose the tunnel is located here, the surface, ground surface, the height of the opening here H above the crown. This height we are recognizing as height of OB, where B is span of opening. In case of rectangular type of opening, in case of circular type of opening, we are considering diameter. So these are some of the approaches in addition to approach made by Tarjagi 1946 and modified by Deere et al. 1970. Then calculation suggested by Barton et al. In 1974 for vertical pressure, for horizontal pressure. Then similar concept for vertical pressure calculated by Anal in 1983 based on rock mass rating system proposed by Beniavsky in 1967 and 1973, and then calculation suggested by R.K. Goyal and Bhavani Singh in 1995, then also suggested by Goyal and Jethwa in 1991, and then the R. Bhasin and Grimstad in 1996. Both are from the Norwegian Geotechnical Institute. In addition to this empirical relationship, and day by day we are utilizing to develop some empirical relationship for calculation of rock load, there is a lot of site for working in this direction. We are still lacking for exact calculation of vertical pressure and horizontal pressure, particularly in squeezing and swelling ground conditions, where we are encountering lot of uncertainties regarding the behavior of ground, particularly in Himalayan area, Alps area and active mountain chains. Next approach is a semi-empirical approach. The semi-empirical approach, this method is a very old method widely used to assume loosening zone. This loosening zone, as per our concept, as we have already discussed, is created due to excavation of opening. We have already discussed. When we are going to create any opening in any rock strata, then there is a development of damage zone, and this damage zone is going to create lot of problem in form of rock load. So this method is old and still widely used method, assuming a loosening zone created about an opening following the redistribution of stresses induced by excavation. According to this concept, it is assumed that the geoground arch about the opening occurs, and the boundary of the loosening zone are the lower side of ground arch and the upper surface of the opening. Considering this concept are assumptions based on this development of the ground arch based criteria. The fundamental reasoning for this assumption originates from the fact that the rock mass is incapable of resisting the tensile stress condition, however capable to survive with compressive stress condition. Therefore, as per this concept, we are going to select a situation or design the engineering structure so that the major part of engineering its structure follow under compression stress zone. So resting to tensile stresses and has a sufficient resistance against compressive stresses. To determine the boundary of loosening zone, one can find numerous semi-theoretical, semi-empirical solutions based on calculation and based on slightly thumbs rules and workable laws. In semi-theoretical proposal, the proposal of Tarjhangi, which was based on the concept provided by Jensen in very early 1895 for Swayam, and the concept proposed by Jensen in 1995 was further utilized by Tarjhangi in 1943 for tunnel. Although Johnson in 1895 proposed his rule and concept for soil only, and that concept was applied by Tarjhangi in 1943 to tunneling, particularly for his assignment at that time to create a railroad in Alps for double-deck facility. For a cohesive ground, the rock pressure for unit width, the Johnson has determined for calculation of vertical pressure, and same concept was utilized by Tarjhangi for calculation of vertical pressure or rock load or ground pressure, utilizing the concept of formation of loosening zone. The Tarjhangi expressed that the tunnel pressure is caused by gravity of all upper strata of the tunnel, and that the pressure is correlated with gravity of the rocks and the frictional coefficient and cohesion of rock mass occurring on both sides. As per rule, when we are going to create this opening, then due to creation of this opening there is a development of a loosening zone. This developed loosening zone started moving toward the downside, means causing some rock load or ground pressure. To counter the rock load or ground pressure, we required some support system to stabilize or protect this movement. To protect this created opening for safety as well as economical restoration. So this concept was based on the concept of the frictional resistance regarding this tensile stress condition and compression stress condition. If you see, the distribution of stress along X is represented by this, along Z is represented by this. You can see these both is going to merge at a certain point. Here also in downside you can see merge, but after reaching some extension value. This concept covering the length of a particular opening can be calculated following the concept given by Johnson in 1895 and modified and utilized by Tarjhangi in 1943. Vertical pressure or vertical ground pressure can be calculated as unit weight of rock multiplied by span of opening minus 2 cohesive strength of rock divided by 2 times the coefficient of lateral pressure into tangent of the angle of friction angle of rock. This component again multiplied by 1 minus e power minus a0 and the depth of loosening zone from the crown, this Z from the top of the loosening zone to the top of the opening, plus P0 pore pressure e power minus a0 Z, where a0 can be calculated as 2k0 tan phi divided by span of opening. In this way we are going to estimate about ground pressure or rock load in terms of the vertical pressure, where this gamma is representing unit weight of rock, B is opening of width, Cu cohesion or cohesive strength, K0 is lateral pressure coefficient that we are utilizing in case of soil proposed by Rankins or other in form of constant we are utilizing in case of retaining walls. Phi, angle of friction of rock, Z is the depth from the surface of this loosening zone, and A0 is representing 2K0 tan phi by, where H is representing major and H is a minor, have relationship 1 minus K by 2K, where the tangential stress will be 0. Covering this concept where the tangential stress will be 0, we are going to design an opening. If the opening is elliptical in nature or elliptical in geometry shape, where the tangential stress we are going to observe as 0. As per this concept of the semi-theoretical or semi-empirical approach, the created opening unable to sustain with tangential stress, in tangential stress condition, this created opening induced formation of damage zone is showing lot of fall, lot of failures and others due to weak nature. However, the damaged rock can survive under compression or compressive stress. Therefore, in case of the elliptical shaped opening, the formation of damage zone is shifting toward the compression. If the major axis and minor axis, this is the H max, and minor axis H minor is equal to 1 minus K0 by 2K0. This K is related to lateral pressure coefficient applied in case of soil, because this concept was taken from the concept of Johnson in 1889 that was proposed for soil originally. But later on, the Tanjhagi in 1943 had utilized for the tunnel rock load or ground pressure. Friends, this concept was developed based on the paper written by Janssen H.A. in 1895 on experiment on grain pressure in soil. It is originally in German, but now we have received English translation. Volume 74, 32 number, page 681 to 695. Then the original paper on engineering classification of rock mass for design of tunnel support, published in Rock Mechanics Journal in volume 6 by Barton, Nick Barton, Leonard and Lundege in 1974, between the pages 852 to 864. Then taken help from the book Tunneling in Weak Rocks, published and edited, published by Elsevier Geoengineering book, written by Singh Bhavani and Goel R.K., edited by Professor John A. Hudson, Imperial College London. Then Concept of Tarjagi from the Theoretical Soil Mechanics book, published from New York Billy publication. Then Concept of Tarjagi as partial support in Tarjagi K for rock tunneling with steel support, written in 1946. Then the book written by the Satyanarayana Bhutkuri and Katsuyama in 1994, Introduction to Rock Mechanics, published in Japan, and partial support from the Engineering Geology book as a supportive, written by Bell. Friends, the empirical approach proposed by various researchers are also found suitable for estimation of rock load with advances in this subject. The semi-empirical approach is an old method but is still widely used due to its application oriented calculation. This concept related to semi-empirical approach is simple and based on calculation having physical background. Then as per concept of semi-empirical approach, they have suggested about the elliptical shape as a shape opening for maximum stability. The in situ stress is playing important role in formation of loosening zone and useful in determination of the ground pressure. Dear friends, in this class we have elaborated about concept of empirical approach except concept given by Tarjagi in 1946. Here in this class we have utilized the concept of Johnson in 1895 was very old and proposed for Swayam, then utilized by Tarjagi in 1946 for tunnel under the concept of semi-empirical approach. So, empirical approach attempted by Barton et al., attempted by Goel and Jetwa, attempted by Annals and attempted by many coming workers, along with semi-empirical approach proposed by Tarjagi in 1943 is going to help in this class. In next class, we will elaborate about structural defect approach. Thank you.